Today I want to talk about my project, Dynamic Building Facade Design Office Building in London. My project content, site analysis, climate analysis, sustainable assessment method, methodology, concept design, and IES analysis. Sustainability is the ability to exist and develop without debuilding natural resource for the future. The United Nations defines sustainable development as development that meets the need of the present without compromising the ability of the future generation to meet their own needs. The most challenge facing designer in an effective shading system that can maintain a balance between harvesting daylight and maximizing visibility while reducing the risk of discomfort and the energy load on the building. Site analysis. The site of a project located in London. The site is bounded by Millington Road to the southeast and northeast, which near of Dowley Road to the northwest. To the south, the site is bounded by a light industrial unit, and the site is on the western edge of the Park Heights status, which comprises a series of modern office buildings and an Asida superstore. The broader surrounding area tends to comprise of post-war housing commercial land in London. Climate analysis. During climate analysis, modern London has the equable climate of southeast England with mild winters and temperate summers. The average daytime air temperature is 52 Fahrenheit with 42 Fahrenheit in January and 65 Fahrenheit in July. My concept design dependent and louver shading system. The concept of the facade is to use louver panels that move in different directions dependent on environmental factors such as sunlight and daylight. It's made of wooden materials moving at different angles. The construction of building from RCC and the stone is dark to absorbing heat because the building in cooling area UK. These sketches show the adopted design method and its working mechanism will be presented after analysis. Environmental assessment method. Sustainable assessment method PREAM have a regulation in design such as maximum U value. The maximum U value allowed in PREAM in wall 0.15 watt per square meter Kelvin, in window glazing 1.7 watt per meter square Kelvin, in roof 0.15 watt per meter square Kelvin. IES analysis. First, I want to make analysis for base case. The base case including ground and 3-story. I use IES program for making analysis or simulation for base case. First strategy, thermal simulation. I calculated annual total energy, annual cooling loads, and annual heating loads for total building G plus 3. In thermal profile, the set point of heating load operation profile in continuously at 21 Celsius degree. The set point of cooling load operation profile and continuously at 23 Celsius degree. In this chart, we see the result from calculating the heating loads, cooling loads, and total energy. The result of total energy is 203.78 megawatt per hour. For cooling, 24.16 megawatt per hour. For heating, 57.29 megawatt per hour. In this chart, appearance, the current condition analysis for 3-story only without ground, first, second, and roof. There is different in result. For total energy 156.27 megawatt per hour. For cooling 22.95 for 43.01 megawatt per hour. In this chart, total energy, cooling loads, heating loads for first, second, and roof for the building. And in the chart, appearance, the heating month and the cooling month in UK. For base case construction materials for building, we follow the PREAM, CIPSE. This is the information about the external wall, exposed floor, which follow the PREAM regulation. This is a schedule for interior ceiling, floor, and interior partition construction, which follow PREAM. This chart, appearance, the suncast for base case for all month and year. This is analysis for solar bath in 3 months in same date and same time. First in July in summer semester. So the solar bath or the solar in the highest point in July. I make analysis for the base case from many of strategy. First strategy, orientation. I put the base case in 4 direction and I get a result, a sum total result. The minimum or the efficient result is minus 90 degree. The efficient direction is minus 90 degree, sum total energy 155.21 megawatt per hour. The second strategy for efficient case, improving insulation. I change the material insulation to polyvinyl poured in existing wall 300 millimeter, and the result of total energy 153.59. Third strategy, improving glass properties. I change from double glass to triple glass. I make analysis for dynamic kinetic facade. There is many of a strategy or scenario. First scenario, use vertical louvers, and I get the total energy 149.98 megawatt per hour. I use vertical louver by angle 20 degree in July, and I get a result for total energy 150.14 megawatt per hour. This chart for air temperature analysis. This is dry bulb temperature in London, and the temperature different according in different by month and season. In this case, and I make study for air temperature and solar gain analysis for base case in different time, in summer, in winter, and in autumn. In summer, May 30, the maximum value of air temperature is 35.19, and in September the maximum value of air temperature 31.15, and the maximum value of December 13.430 Celsius. Air temperature and solar gain analysis for optimized case in 3 month, 3 time, in day, in 3 strategy. In first strategy, louver installed in different tilted degree 0, 20, 45 degree, and in the southeast. The louver in south and east, and we get the result in 3 months, in May summer, September autumn, and December winter, and we get the result in 3 time. This is a result for 3 direction in 3 months, in 3 different time. The best result in southwest tilted 45, which have maximum value near of comfort zone. In this 3 scenario, 3 different direction and 3 different month and 3 different time. The best result in southwest and east tilted 45. The maximum value in May 25.65 Celsius and September 22.76. So the average or the range between May and September in the comfort zone. The optimized case is in southwest east tilted 45, which have lowest value especially on May summer and on September autumn. Daylight analysis including daylight glare, daylight factor, illuminance value and radiance contour. Daylight, there is 4 of scenario in different time and different season. In winter, December 12 p.m. there is base case and kinetic case optimize. The radiance contour in base case different than kinetic case. In winter, December 12 p.m. the daylight glare in base case 6.71%, but in kinetic case optimize 2.08%. In winter, December 12 p.m. when the illuminant value in base case 136, the illuminant value in kinetic case 59. In base case, the day factor 32. In kinetic case, still 32 because the semester in winter. In autumn, September 12 p.m. base case and radiance value different in amount in kinetic case optimize. In autumn, when the daylight glare in base case 20.72%, the daylight glare 12.16% in kinetic case. In summer, May 9 a.m. when the value of elements 332 in base case, the elements value in kinetic case 157. Natural ventilation. In natural ventilation analysis, external air velocity in base case, the wind rose annually maximum airflow in southwest. This chart for measure range value of air velocity in different site. This chart for measure range value of air velocity in different site with louver shading in kinetic facade. This analysis for interior air ventilation shows the range of air velocity and air temperature in the room. The range value between 24 and 27 kC. In scenario is that the heating and cooling system is closed and the windows are open 50%. Cross ventilation in summer May. In base case, the range between 17 and 19 and kinetic case between 16 and 19. The result of my study analysis for the basic case of the project and used efficient kinetic facade design. The kinetic case was improved to reach the comfort zone.